Good evening, all dear students. Let us have discuss the question here. We are in exercise 4f determinants concept. Prove that determinant is independent of theta. So first you have to write the given determinant and expand just x sine theta cos theta minus sine theta minus x 1 cos theta 1 x. So here plus minus plus. So which is equal to x into minus x square minus 1 minus sine theta into minus x sine theta minus cos theta. Next plus cos theta into minus sine theta plus x cos theta. So which is equal to minus x cube minus x plus x sine square theta plus sine theta cos theta. Next minus sine theta cos theta. Next plus x cos square theta. Sine theta minus sine theta cos theta cancel. So which is equal to minus x cube minus x. From these two take common x. Cos square sine square theta plus cos square theta. So minus x cube minus x plus x into 1. So which is equal to minus x cube minus x plus x, which is equal to minus x cube, which is independent of theta. Independent of theta. That means it does not contain any theta value. Okay, dear students, I hope you understand. We'll move on to next question, which is independent of theta. We proved. Let us discuss this question. Next question. Evaluate cos alpha, cos beta, cos alpha, sin beta, minus sin alpha. Just normally you can expand, dear students. You will get the answer. So expanding, we know that how to expand plus minus plus. So cos alpha, cos beta into cos alpha, cos beta minus 0. Next minus cos alpha sin beta into minus sin beta cos alpha minus 0. Next minus sin alpha into minus sin beta into sin alpha cos beta minus cos beta into sin alpha cos beta. So just normally we are expanding. So cos alpha cos beta into cos alpha cos beta, cos square alpha into cos square beta, minus into minus is plus, cos square alpha into sin square beta. Next from here, minus into minus is plus, sin square alpha into sin square alpha into sin beta cos beta. Plus minus into minus is plus, sin alpha into sin alpha sin square alpha into cos beta cos square beta also. Okay, dear students. Here sin square alpha sin beta, this is minus sin alpha into sin beta into sin alpha into cos beta. Yes, that's what we wrote. Even here also minus sin alpha cos beta into cos beta. Okay. So which is equal to, from these two, cos square alpha, if we take out common, cos square beta plus sin square beta. From here, because here sin alpha cos beta, if we take out common, sin alpha cos beta. But sin square alpha, if we take out common, what happens? From these two, sin square alpha, if we take out common, so here minus sin alpha into minus sin beta, sin alpha cos beta, minus cos beta into sin alpha cos beta. Yes, right only. Minus into minus is plus, sin square alpha sin beta cos beta, sin beta cos beta. Next, minus into minus is plus, sin square alpha into cos beta cos square beta. Here only little. So here sin square alpha, if you take sin beta, here sin square beta, dear students, here we need to get it is this will be sin square beta, then it will be correct. If we are taking common, means sin square alpha, if we do that, sin square beta should be there, then only it is correct. Sin square beta. Here it is sin, I only wrote wrong, sorry. Here sin beta. So sin square beta plus cos square beta. So which is equal to, this value is 1, cos square alpha into 1 plus sin square alpha into 1. So which is equal to cos square alpha plus sin square alpha. That is equal to 1. Therefore, the given determinant value equal to 1. Yeah, Astakil, thank you for joining. Please like and share. If you like this video, it reaches to more students. That is my intention. See here, this question we'll do in the different way. Row operations, column operations. If you want directly also, we can expand. But instead of that, what I am going to do is, whenever 3 ones will come in the column or row, make them 2 zeros, 2 ones, make them 0. So R2 tends to R2 minus R1. R3 tends to, this is R2, dear students, this is R3. R3 minus R1. So R1 we are not disturbing. R1 as it is we are writing 1xy. R2 tends to R2 minus R1 means 1 minus 1, 0. X plus y minus x, so that means y. Y minus y, 0. Next, R3 tends to R3 minus R1, 1 minus 1, 0. X minus x, 0. X plus y minus y, so x. So we observe that it is a triangular matrix. The above determinant, the determinant of triangular matrix is, the determinant of triangular matrix is product of diagonal elements. Product of diagonal elements. So which is equal to 1 into y into x. So which is equal to xy. That's what answer. Xy is our answer, dear students. If you do not know about this method, as usual method, we will go like normal expanding. Plus minus plus 1xy, 1x plus y, 1x x plus y. So which is equal to 1 into x plus y whole square minus xy minus x into x plus y minus y plus y into x minus y. So x square plus y square plus 2xy minus xy minus x square minus y square plus x square minus x square plus y square minus y square 2xy minus xy, that is equal to xy. Alternate method also we finished, dear students. Okay, we'll move on to other question. The alternate question, the next question, second bit first question. It is A inverse we got, but they are asking to find B inverse also. To get AB whole inverse, we have formula B inverse into A inverse, no? So A inverse already given, B inverse I want to calculate. So before going to calculate B inverse, determinant of B can calculate. So det B is equal to, determinant of B is equal to, so B matrix we are writing 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1, 1 into 3 minus 0, minus 2 into minus 1 minus 0, minus 2 into 2 minus 0, 3 plus 2 minus 4, which is equal to 1 is not equal to 0. So det B is equal to 1 and which is not equal to 0. That implies B inverse exists. So adjoint B we will calculate. Adjoint B is equal to transpose of cofactors matrix. So we are writing that cofactor matrix from 2 days. These live sessions are going on, no? So in what way we are going? So from here, 3, 0, minus 1, 3, minus 2, 1, 0, again minus 2, 2, minus 2, 1, 2, again 3, 0, minus 1, 3. So now calculate the determinants of this 3 minus 0, 0 minus of minus 1 plus 1, 2 minus 0, 4 minus 2, 1 minus 0, 0 minus of minus 2, 0 minus of minus 6 plus 6, 2 minus 0, 3 minus of minus 2, 3 plus 2, 5. So adjoint B is equal to, so transpose of a matrix, that means 3, 2, 6, 1, 1, 2, 2, 2, 5. After that, B inverse is equal to 1 by det B into adjoint B. So 1 det value is 1, no need of writing, this is only. Therefore, B inverse is equal to adjoint 3, 2, 6, 1, 1, 2, 2, 2, 5. Since det A is equal to, det B, dear students, det B is equal to 1. So therefore, AB whole inverse is equal to B inverse into A inverse. So B inverse we got it. 3, 2, 6, 1, 1, 2, 2, 2, 5. And A inverse it is given in the given question. This is the given question, dear students. So what is the value? 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. So normal multiplication. 3 3 is 9, minus 30, plus 30. 9, next. Minus 3, plus 12, minus 12. Next, 3, minus 10, plus 12. 3, minus 15, plus 10. Minus 1, plus 6, minus 4. 1, minus 5, plus 4. 6 minus 30 plus 25 minus 2 plus 12 minus 10. 2 minus 10 plus 10. So 9 minus 3. 12 plus 3, 15 minus 10. 15 minus 10 is 5. Next 10 plus 3, 13. 13 minus 15 minus 2. 6 minus 5, 1. 5 minus 5, 0. 25 plus 6, 31 minus 30, 1. 12 minus 2, 10. 10 minus 10, 0. These two will be cancelled, 2. Therefore, the value of AB whole inverse is equal to 9 minus 3, 5 minus 2, 1, 0, 1, 0, 2. I hope you completed. We'll move on to the next question, dear students. The next question is evaluate, question number 2. Evaluate determinant of x, y, x plus y, y, x plus y, x, x plus y, x, y. Dear students, to solve this problem, normally we can do, we done already question number 3, this type of problem. But here what I am doing is, here x plus y, x plus y. If you apply, on applying, C1 tends to C1 plus C2 plus C3, column 1 plus column 2 plus column 3. In column 1, what happens? X plus y plus x plus y. 2 times of x plus y, are you getting? Next, y plus x plus y plus x. Again 2 times of x plus y, dear students. Next, again x plus y plus x plus y. That means 2 times of x plus y. So the rest of the values, y, x plus y, x, x plus y, x, y. Now, taking common, taking 2 into x plus y common from C1. So, which is equal to 2 times of x plus y. So 1, 1, 1, y, x plus y, x, x plus y, x, y. So I already done in the previous question, question number 3. When in column or row, three ones are there, make them 2 ones zeros by using row or column operations. According to this question, row operation, this one, I'm going to make 0. So R2 tends to R2 minus R1, R3 tends to R3 minus R1. So after doing of this step, 2 times of x plus y, R1 as it is we are writing 1y x plus y, 1 minus 1 0, x plus y minus y, that means x minus y, so minus y will come. Here 1 minus 1 0, R3 minus R1, 1 minus 1 0, x minus y. Next, y minus x minus y, so minus x. After that, expand along with column 1. Expand along C1. So 2 times of x plus y into expand along with column 1 means, dear students, this is the way we can. So the rest of them, no need of doing this one. So 1 into determinant of this one. X into minus x square minus y into x minus y. So 2 times of x plus y into minus x square, minus into minus is plus, y into x minus y. So 2 into x plus y minus x square plus xy minus y square. Are you all getting, dear students? Here 2 into, if I take common from these two terms, minus I am writing here x plus y into x square minus xy plus y square. We know that a plus b into a square minus ab plus b square is a cube plus b cube formula. So minus 2 into x cube plus y cube. This is the final answer, dear students. I hope you understand. We'll move on to the next question. So this is the way we can expand. So go to the question number 3. So what is the question number 3? Show that determinant of y plus z x y z plus x y z x plus y is equal to 4xyz. So they are asking to prove this result. We will prove it. So consider LHS. LHS means given. LHS determinant of y plus z x y z plus x y z x plus y. So what I am going to do is, normally we can do. Here there is no possibility for taking off common like okay. So normally you can expand. Normally expanding means y plus z into z plus x into x plus y minus zy. Next minus x into y into x plus y minus zy plus x into yz minus z into z plus x, which is equal to y plus z zx plus zy plus x square plus xy minus zy plus zy minus zy get cancelled. Next minus x into xy plus y square minus yz plus x into yz minus z square minus zx. So which is equal to, here y plus z means y plus z is bracket here, students. So first multiply each and every term with y. So x, y, z completed. Next x square y completed. Next x y square is over. Next with z, x z square plus x square z. Next x y z. So first term finished. Next minus x square y minus xy square plus xyz plus xyz minus xz square minus zx square plus xy square minus xy square cancel plus x square y minus x square y cancel plus xz square minus xz square cancel plus x square z minus x square z cancel xyz plus xyz plus xyz plus xyz 4 times of xyz. It is required RHS, dear students. Now question number 4. Show that determinant of ABC BCA CAB whole square is equal to A cube plus B cube plus C cube minus 3ABC whole square. Here you have to consider LHS. Det ABC BCA CAB whole square. Whole square means we can write it as product of two determinants now. ABC BCA CAB ABC BCA CAB. If you interchange two rows or columns, the sign of it will be changed, Even another method also we will go, dear students. So det of this one we will calculate and det of another one also we will calculate. So better to do determinant of ABC, BCA, CAB value. So now det ABC we are calculating BCA, CAB. So plus minus plus A into BC minus A square minus B into B square minus AC plus C into AB minus C square. So which is equal to ABC minus A cube minus B cube plus ABC plus ABC minus C cube. Here I am writing, dear students. So det of ABC, BCA, CAB is equal to 3ABC minus A cube minus B cube minus C cube. This we can write it as minus take common A cube plus B cube plus C cube minus 3ABC. This is about det ABC, BCA, CAB. Equation 2 substitute in equation 1. We get, so determinant of ABC, BCA, CAB whole square equal to minus A cube plus B cube plus C cube minus 3ABC whole square. So which is equal to A cube plus B cube plus C cube minus 3ABC whole square, which is required RHS. Okay, dear students, I hope you understand. We'll move on to third bit. Second bit also completed. We'll move to third bit. In the third bit, we have, in third bit, let A is equal to, let capital A equal to 121, 231, next 115. Verify that the first question, adjoint A whole inverse is equal to adjoint A of inverse, adjoint of A inverse. Second one, A inverse whole inverse is equal to A. See, one by one we will finish it, dear students. So first, determinant of A calculate. Why? Because to exist A inverse we need to calculate. 121, 231, 115. So we know the procedure to expand the determinant. 1 into 15 minus 1 minus 2 into 10 minus 1 plus 1 into 2 minus 3. So 14, 10 minus 1 is 9, 9 2 is 18. So 18, 2 minus 3 is minus 1. So 14 minus 19 is minus 5, not equal to 0. Det A is equal to minus 5, which is not equal to 0. That implies A inverse exists. So first calculate adjoint of A. So adjoint of A is equal to transpose of cofactors matrix. So first we are writing the cofactors matrix. 3, 1, 2, 3. Next 1, 5, 1, again 1, 2, 1, 1, 2. Next 3, 1, 2, 3. So we know that how to do this. Fifteen minus 1, 14. 1 minus 10, minus 9. 2 minus 3, minus 1. 1 minus 10, minus 9. 5 minus 1, 4. 2 minus 1, 1. 2 minus 3, minus 1. 2 minus 1. 2 minus 1 is 1. 3 minus 4, minus 1. So for this transpose I want. So transpose of this matrix. So adjoint A. So therefore adjoint of A is equal to, after transpose, dear students, 14 minus 9 minus 1 minus 9 4 1 minus 9 4 1 minus 1 1 minus 1 minus 1 1 minus 1. This is about adjoint A. Okay. So they are asking to find adjoint whole inverse is equal to adjoint A inverse. First A inverse, if you calculate, automatically it comes now. So A inverse is equal to, A inverse is equal to 1 by det A into adjoint A. So which is equal to 1 by det A value minus 5 into adjoint A, 14 minus 9 minus 1 minus 9 4 1 minus 1 1 minus 1. This is about A inverse. So first question is what? Adjoint A whole inverse is equal to adjoint A of inverse. A inverse we got it, no? A inverse we got it. Again for this, if you calculate inverse, for this we need to go for verification of properties, dear students. Otherwise, it is not easy to. So first one, we completed the determinant. Exactly, we got it. Next, question number 1, verification is there, no? What is that verification? Adjoint A whole inverse. So that means for adjoint A, we have to calculate the determinant, dear students. So calculate determinant of adjoint A. So we know that determinant of adjoint A is equal to formula we have. What is that formula we have? Determinant of adjoint A is equal to det A whole power n minus 1. What is det A we got? Det A value is minus 5. N is order of the matrix 3 minus 1. So minus 5 whole square, which is equal to 25. So determinant of adjoint matrix is 25. Now for adjoint matrix, calculate to get inverse now. Again we need to calculate the cofactors of the adjoint matrix. Directly I am writing adjoint of adjoint A. So adjoint of adjoint A is equal to transpose of, for this we have to write it 4 1 minus 9 again 4 1 minus 1 minus 1 1 minus 9 minus 1 14 again minus 9 4 1 minus 9 4. So later minus 4 minus 1 minus 5 minus 1 minus 9 minus 14, sorry, minus 1 minus 9 minus 10. I am very sorry. Next, minus 9 plus 4 minus 5. Next, minus 1 minus 9 minus 10. Minus 14 minus 1 minus 15. Next, 9 minus 14 minus 5. Minus 9 minus 9 plus 4 minus 5. 9 minus 14 minus 5. 56 minus 81. 25. So after that transpose we need to calculate minus 5 minus 10 minus 5 minus 10 minus 15 minus 5 minus 5 minus 5 minus 25. So later what we have to do, so adjoint A whole inverse is equal to 1 by determinant of adjoint A into determinant of adjoint A into adjoint of adjoint A. So 1 by 25 into minus 5 minus 10 minus 5 minus 10 minus 15 minus 5 minus 5 minus 5 minus 25. So dividing by 5, that is your wish, dear students. So like this we can make it. 5 ones, 5 fives, that is minus 1 by 5. 5 twos, 5 fives, minus 2 by 5. So that is plus 25 only. Next, minus 25 minus 1 by 5. Minus 2 by 5. 5 3s are 5 5s. Minus 3 by 5. 5 ones, 5 5s. Minus 1 by 5. Minus 1 by 5. Minus 1 by 5. Minus 1. So this is about, we need to verify now. So adjoint whole inverse, we got it. Next, adjoint of A inverse. This is A inverse, no. For this, this is equation number 1, you can write it, dear students. Next, we calculate. So they are asking to prove adjoint of A inverse. This is A inverse matrix. A inverse matrix, this is for this adjoint. So adjoint of A inverse is equal to adjoint of A inverse equal to properties for that. So already minus A inverse value is no adjoint of minus 1 by 5 adjoint of adjoint A. So A inverse, adjoint A inverse, no. So adjoint A inverse is minus 1 by 5 first. Minus 1 by 5 whole square. Adjoint, they are asking to prove, see this result. Adjoint of A inverse property is there. Adjoint of A inverse is equal to. So minus 1 by 5 whole square into adjoint of adjoint A. So what, which is equal to 1 by 25. Adjoint of adjoint A, we got it now here. Minus 5, minus 10, minus 5, minus 10, minus 15, minus 5. Next, minus 5, minus 5, minus 25. So by observing the data from 1 and 2, this is second equation. Here we applied the property, dear students. Here what property I applied is, here I will write it, that is better to understand. Adjoint of A inverse is equal to adjoint, using the property adjoint of this is K, dear students. K into A inverse. Better to write in another way. Adjoint of K into M. M is any matrix. K is any constant. K is constant. That is equal to adjoint. M is a matrix. M is any matrix. M is a matrix. So adjoint of K into M is equal to K power n minus 1 into adjoint M. So here, in place of M inverse, I have to write it. So now adjoint of minus 1 by 5 into, this is A inverse, this value, this matrix, M is equal to minus 1 by 5 whole power, this is third order, no, 3 minus 1 is 2 will come. Next, adjoint of that M. According to the question, M is where M is equal to. Where M is equal to here A inverse, students, that is 14 minus 9 minus 1 minus 9 4 1 minus 1 1 minus 1.